6x, because 12 divided by 2 is 6. I had 2 x's, and I'm getting rid of one of them. And on the bottom, 2x divided by 2x is 1. Now, ideally, you would not leave it as 6x over 1. You would just write 6x, okay? Because that over 1 is not necessary. Okay, now the second problem here it's already been factored for us, which is a nice situation. We just need to write our non-permissible values and then start to simplify. When something's been factored already, don't expand it out. That's a bad idea. Okay, so here, my non-permissible values for A, I have 2 of them because I have 2 factors in the bottom. I have A plus 7 and A plus 1. So what goes with A plus 7? Negative 7. And plus 1? Negative 1. Okay? Then you look at the top and the bottom. And again, it's pretty similar. It's a little different when we're dealing with factors. Is you're looking at it and you're asking yourself, what do they have in common? What is the same on the top and the bottom? Okay, so on the top and the bottom of this one, what's the same? A plus 1. So really what we're doing, what I do is I just cross them off. But the reason that I just cross them off is because I'm dividing both the top and the bottom by A plus 1. That's the reason behind it. Just like how in the last question I was dividing by 2x, now I'm actually dividing by A plus 1. But what ends up happening is that they just cancel off. So what's left is A minus 6 over A plus 7. But it's really, really important that you understand that you can't just cross something off that looks the same. You have to cross off an entire factor. So here, A plus 7, A plus 1, A minus 6, those are factors. So what I would see happen a lot is that students would get down to this step and I would see them cross off the A's. Because they're like, oh, they're the same on the top and the bottom. But that's not how you actually do it. Because A minus 6 is a factor. So if you want to cross off part of it, you have to be able to cross off the whole thing. Okay, so you cannot just cross off a piece of it. Okay, you have to cross off the entire factor, and factor means multiplication. So A minus 6 is not 2 factors. Okay, it's not A and negative 6 or something like that. It's A minus 6 together that makes 1 factor, so you can't cross it off. That's something that kind of just takes practice until you realize what you can and can't do. But it is really important that you don't try crossing things off that shouldn't be crossed off. Okay, so this next one, the bottom can't be factored, so I can right away write my non-permissible value. If the bottom there is 8y, what's my non-permissible value? 0, because 8 times 0 is 0. Okay, now this one can be factored, or you could do it without factoring, either way. Honestly, I would kind of probably do this one maybe without factoring. I would just look at all 3 terms and look to see what they can be divided by. So what can all 3 of them be divided by? 2. So if I divide everything by 2, if I divide everything by 2, I get 4y plus 1 over 4y. And again, you cannot cancel off the 4 y's here. Okay, they don't cancel because they're not factors. If you wanted to cancel something, you would have to be able to cancel the entire factor 4y plus 1, okay, which you can't do because there's not an identical one down below. Okay, so this is simplifying rational expressions. These ones are all pretty easy because they can all be done without factoring. We'll look at some that require factoring, and then we're going to have some time to finish that assignment. And then after that, we'll probably work on the assignment for 10-15 minutes. Then we will start to look at multiplying and dividing. Okay, so here are some that do require factoring. So this first example here, x plus 7 over 49 minus x squared. If the denominator requires factoring, you should do it before you find the non-permissible values. Here the denominator does require factoring. What type of factoring is that? That's, yeah, the difference of squares. So instead of 49 minus x squared, I can write what?
X minus 7 and x plus 7.
Close. This one's a little different because that would be what it would be if it was x squared minus 49.
7 minus x.
It is going to be 7 minus x and 7 plus x. They are different, unfortunately, because the x squared has to be negative when it multiplies out. But that's difference of squares. So you should be familiar with difference of squares. It's going to come up a lot. Okay, so knowing that you just take the square root of the first number, take the square root of the second number, or term, and make them 1 plus, 1 minus. Now here, what's the same on both the top and the bottom? The x plus 7. And notice how the whole thing's the same. I'm not just crossing off an x, or just the 7. It's x plus 7. The entire factor is the same. So I can cross it off, and I can cross this off because they're the same. Now, on top, everything's crossed off. So a common mistake that I see students do is they write, oh, so it's just 7 minus x, and they write that as the answer. That's not correct, though, because that 7 minus x is in the denominator. It has to stay in the denominator. It can't suddenly move up and be part of the numerator. So I have to keep it down there. What do you suppose I should put on top?
1.
Yeah, 1. So if everything cancels off, you put a 1. Okay, now this one, the non-permissibles, you always look at the step where you factored. So I look back to this step, and even the ones that got canceled off still get considered in your non-permissible values. So I have 2 non-permissible values there. I have 1 for 7 minus x, and 1 for 7 plus x. So what would it be for 7 minus x? 7. And for 7 plus x? And minus 7. Okay, so those are my 2 non-permissibles. So even though one of them got crossed off, it's still a non-permissible. Okay, so this next one here, this is a pretty typical type of problem. There's factoring to be done for sure on both the top and on the bottom. You could maybe do a lot of work without factoring, but you should be factoring in a problem like this. So when you have 2 terms on both the top and the bottom, like this one, you should definitely factor. Okay, so you know, hopefully you see what I mean when I say 2 terms. I have 1, 2, 1, 2. Okay, I have 2 terms on both the top and the bottom. You should be factoring. So on top there, if I look at 12p squared and 8p, what's a common factor between them? 4, and anything else? And a p. So it's important to factor out the most you can. So 4 is the highest number that goes into 12 and 8, and p is the most number of p's that I could possibly take. So in my brackets, what's left is 3p, so because 4p times 3p is 12p squared, minus what? 2. Okay, over, and then I do the same thing with 6 and 4. So what's the highest number that goes into 6 and 4? 2, and how many p's can I take? P squared, perfect. So it's always the least number of p's, so there's one of them has a p squared. Then what's left over is 3p minus 2. Okay, and see, that's not like a miracle. That is usually going to happen where the factor is the same, which is why you have to factor. If you didn't factor, you wouldn't be able to see that, and you'd probably get the question wrong. So at this point, you could write your non-permissibles if you wanted to write them before things got too complicated. So looking at the factors, I have 2p squared, and I have 3p minus 2. So for 2p squared, what's the non-permissible for that? It is 0. Some people are whispering it. Okay, it's 0. If there's no plus or minus, but there is a p, it's 0. Then for this one, 3p minus 2. Does anyone remember from yesterday what the rule is?
2/3.
It is 2/3. Okay, so you add 2, divide by 3. So it's 2/3. You could do that out more slowly. If you're having trouble with that, let me know, and I'll walk you through it step by step. Now I should cancel off things that are the same. So what's the same on the top and the bottom? 3p minus 2. So that can cross off. What else could I divide by? I could also divide by 2p. So I'm going to divide by 2p and divide by 2p. If I do that, I get 2 on top, because 4p divided by 2p is 2. And on the bottom, I get what? Just p. That's right. Okay, because 2p squared divided by 2p is just p. So this simplifies all the way down to 2 over p. Yeah, which is pretty simple. Not like simple to do, but it's quite simple at the end. It ends up as a nice simple fraction. Okay, so it's really important to factor is the point there. Okay, let's do one more with some factoring, because I know there's people in the room who don't know how to factor. So please, watch me do it and try to follow along and actually make sense of what I'm doing. So here, if I'm factoring this, I look at the top, and I think about what number goes into both 2 and 4, and it's 2. You want it to be the highest number, so 2 is the highest number, there's only one choice. And then with the p's, you look at them and you're like, okay, there's 3 p's, p cubed, and 2 p's. So the highest that can come is 2. So I take out p squared. Okay? Then what's going to be left in the brackets, I am always thinking about what do I have to multiply 2p squared by to get 2p cubed? And the answer is there's just 1 p missing. So I have 1 p inside the brackets minus 2, because I'd have to multiply 2p squared by 2 to get 4p squared. Then on the bottom, 16 and 8. What's the highest number that goes into 16 and 8? 8. And what's going to be left inside the brackets? 2 take away p, or 2 minus p. Now, this one is a really important one. Okay? If I do my non-permissibles now, I can see it's 2 minus p. My non-permissible is 2. Is there one here for the 8? No, because there's no p there. Okay, so 8 is never going to equal 0. No matter what I plug into p, because there is no p, 8 is not always just going to be 8. So there's no non-permissible that goes with that. Now this one's really important. I'm going over it for a reason. It's because there's p minus 2 on the top, and there's 2 minus p on the bottom. Okay, now that really feels like it'd be nice if it worked, but are they actually the same? They're not really the same, at least not yet. Okay, like 5 minus 2 is not the same as 2 minus 5. Okay, they're not equal, because 5 minus 2 is 3, and 2 minus 5 is negative 3. So what you have to do when you have a situation like this is you can cancel them, but there's a trick, because what they are is they're opposites of each other. One of them's positive, one of them's negative. When you divide a positive by a negative number, what do you get? You get a positive or a negative? You get a negative. So there's a special rule in this case. It's that you can cancel them, but when you do it, you have to put a negative out front. Okay, I always just put it with the top thing, whatever's up top. Okay, the reason for that is because I know one of them will be positive, one of them will be negative, so I'm dividing a positive by a negative, and I'm getting a negative number. So there should be a negative somewhere. Okay, so it's a trick that you have to kind of remember. They actually really like putting these on the diploma exam, I think, because they're sort of like a standard of excellence type question, like for a student to remember to do that. It's hard. So if you know that rule, it could be the difference between getting a question wrong or right. Okay, so when you cross off 2 that are the opposite of each other like that, you have to add a negative. Now, what else could I do? I have 2p squared and I have 8. Divide by 2. So I'll divide both of them by 2, and I'll get negative p squared over 4. Okay, so that's how you do it. Now, I want to talk quickly about and show you on the calculator how to check these, and ideally how to check them kind of quickly without having to write it down and everything. I believe pretty strong. This section takes up a lot of the departmental, and a lot of the questions, because the departmental is multiple choice, a lot of them can just be done on the calculator, and I don't really see any reason why you shouldn't take advantage of that. So Actually, here, let's go backwards a little bit. Okay, if you have a multiplication problem, and if you were just multiplying two fractions, like say you had something like 2 out of 5 times 3 out of 2, how would you do that question? Does anyone know? Yeah, it's just straight across the top, straight across the bottom. Multiplying fractions is one of the more intuitive things about fractions. It's just straight across, straight across. So here would be 6 over 10. And then you can simplify that. That's divide by 2, divide by 2. So I get 3 over 5. Now, does anyone see kind of a faster way that I could have done that from the start? If I hadn't multiplied right across the top, if I hadn't done that, does anyone see a faster way to do it?
Cross off the 2's.
Cross off the 2's. Okay? So even though they're not in the same fraction, since one of them is on the top and one of them is on the bottom, and they're common, they're the same, you're allowed to cross them off. Okay? That is an important thing when we're multiplying these expressions. Because when, okay, so if you have a multiplication, it's expressions, it's the same idea for a lot of it. Okay? We are going to be multiplying straight across the top, straight across the bottom. But if there's any common factors that are on the top and on the bottom, you can cross them off, even if they're in different fractions. Okay, so here on this one, first of all, notice that it gave us the non-permissibles. Okay, if a question has that there, all it means is that you don't have to do them. Okay, so don't, I always get students to ask me, they're like, what is that nonsense next to it about? That's just the non-permissibles. Okay, so you don't need to even look at them. They don't have anything to do with the problem, really. Okay, so here what I would do right away is I would factor anything that can be factored. And that's going to be the situation for this whole unit. So anytime you have something that can potentially be factored, you should factor it. So here, if I look at this, I have 4 different things. I have 2 numerators, 2 denominators. Which one of them can be factored? There's only one of them. The 2x squared minus 12x. So it's the one with 2 terms that actually has common factors. X minus 6 is also 2 terms, but there's nothing that can be factored out of that. So I would factor 2x squared minus 12x. What's a common factor for those? 2x. So I factor out 2x. So I put 2x out front. Inside my brackets, what would be left? X minus 6. And I mean, it doesn't always work out this way, but a lot of the time it does. So if you're really stuck and you're like not sure how your factoring is going to work, there's a pretty good chance that it's going to look like another factor somewhere in the problem. So now I just, personally when I'm doing these, I just take a look and I look for anything that I can cancel. Just like in that last question, how I could cancel those 2's. I like to look for things like that I can cancel. So is there anything here that's the same on both the top and the bottom? X subtract 6. Anything else? Okay, so if there isn't, or if you feel there isn't, you can start to multiply what's left over. So I have 2x and I have 5x on top. So if I multiply them together, what do I get? 10x squared. And on the bottom, there's just 15x. Now, there's definitely something that I can divide by here. So what can I divide by? 5x on both the top and the bottom. So I end up with 2x over 3. That's my answer, 2x over 3. Now I could have, if I'd wanted to, I could have done some more canceling in the first step. I could have canceled off one of these x's, like the 2x, with the x down here. And I could have divided by 5 and divided by 5. Okay? Then this 5 would be gone. I'd end up with 2x on top and 3 on the bottom. Okay? I could have done that and skipped that intermediate step. But if you aren't someone who sees those things, do it in 2 steps. Okay? So don't rush to try to do it all at once. But if you do see that, if you look at something like this and can see, oh, I could divide by 5 here and there, then do it. As long as you always do the same thing to the top as the bottom. So if I cancel off an x on top, I have to cancel off an x on the bottom. If I divide by 5 on top, I have to divide by 5 somewhere on the bottom. Okay, but either way, I do end up with 2x over 3. Okay, and that's my final answer. And again, I could check that on the calculator. If I type this entire thing in to a calculator, and then I type this into a calculator, it should give me the same value. Okay, as long as I've done it correctly, it should give me the same value. So you can always check. So this is no different than what we were doing, it's just a little longer now. Okay, so let's look at another one here. So here there's a couple different things that can factor. I can factor 3x squared plus 6x, so I will. So if I factor that, what can come out of 3x squared and 6x? 3x, thank you. Someone whispered it very quietly. Okay, and 3x, to get 3x squared, all I'm missing is one more x. And to get 6x, it's going to be plus 2. Times, and now I have 4x cubed and 8x squared, so I can remove a 4x squared. And in my brackets is x plus 2. Okay, you want to be able to factor like really well, basically. There's a lot of factoring in these problems. So you want to be able to do it like without thinking very much, ideally. Okay, so that you just do it, you get going on it. You always make sure you factor out the largest number you can. Okay, and now I'm looking for the things I can cancel. So what can I cancel here? X plus 2. Okay, and you can cancel an x at this point if you want to, or you can leave it. I think a lot of people are probably going to end up leaving them, which is, there's nothing wrong with that. So if we combined what was left over, so I have 12x cubed times 4x squared, which is 48x to the power of 5. And on the bottom, I have 3x and 5. What will 3x times 5 end up being? 15x. Now, does anyone know a common divisor between 48 and 15? What? It is 3, yeah. And I can also remove 1x. So I end up with 16x4 over 5. Okay? And that ends up being the simplified form. Now this one did not give us non-permissibles, so we have to do them. Now it's important when you're doing multiplication that you consider this original step, okay, the factoring step. That's the step you should consider for your non-permissibles. Okay, and you should look at the denominator for both fractions. So I had 3x, I had x plus 2, and I had 5. Those are all the factors that were down in the bottom. So 3x, what will be the non-permissible value? 0. Now x plus 2, the non-permissible would be negative 2. And what about for 5? Nothing. 5 doesn't have an x, so it also doesn't have a non-permissible value. So my final answer here is 16x to the power of 4 over 5, where x cannot be 0 or negative 2. Okay, so all the time, that's why I said these non-permissible values are so important, because if you don't know how to do them, you're going to be getting a lot of questions slightly wrong, okay, which is not a good situation. Okay, so let's look at a few. Okay, a couple. Actually, let's do a fraction one. Does anyone know offhand how to divide something like 8/10 by 3/7? You flip the second one. I see a lot of people doing things that I can tell they kind of remember, which is awesome actually. A lot of time nobody remembers. So it's 8 over 10. You flip the second one, make it 7/3. And the middle, instead of a division now, you have a multiplication. So this ends up being 56 over 30, which is 28 over 15. So that's how you do division with fractions. You multiply by the reciprocal. That's the fancy math way of saying it, is that when you're dividing by a fraction, you multiply by the reciprocal. That's why if you're dividing something by a half, it's the same as multiplying it by 2. Okay? Or if you're dividing it by 2, it's the same as multiplying it by a half. that those opposite things work. So it's the okay. So division. When you have a division here, it's exactly the same as multiplication. Like they are not. Division is not harder than multiplication, other than the fact that you have to remember to flip it. So right away, you just rewrite it. You change it to a multiplication, and you flip the second fraction. Okay, then you're dealing with an exact same type of question. There is a slight difference that I'll tell you in 1 minute. Okay, so we factor everything. Okay, so I factor out a 3x. I get x minus 3. I factor out a 6. I get x minus 3. See, and you kind of know if you're doing it wrong or right, because if you're doing this correctly, there should be something that cancels at some point, like generally speaking. I mean, I guess I could give you a problem where nothing cancels. It would be kind of mean. But usually, like, you're going to end up with something like this, where I can see that the x minus 3's are clearly going to cancel with each other. Okay? Now, when I multiply what's left here, I have an issue. Okay, because I have my 6 and I have my x minus 5. I just really want it to be clear that when I write it, I would just write it like this. I would just write 6 times x minus 5, just like that. I wouldn't multiply it out, and I wouldn't write 6x minus 5 without the brackets. I would just write them next to each other like that. And on the bottom, I have 3x times 5, which is what? 15x. Now, this can be simplified more, because the 6... and the 15 do have a common factor of 3. So I should divide them both by 3. And you could have done that in this step. Like I could have divided by 3 and by 3 up here. And it would have worked just as well, but whichever order you want. So it's 2 times x minus 5 over 5x. Now, the one place that division is tricky is in the non-permissible values. Because the deal is with non-permissible values is you're not allowed to have a 0 in the denominator anywhere at all throughout the whole question. So we flipped this second fraction so that this went up top. But it was still in the denominator at the beginning. So when you're doing division, you actually have to consider all 3 of these for non-permissibles. Because in the second fraction, since it flips, at some point, both of them are in the denominator. So you have more non-permissibles when it comes to division. This is another question that I've seen come up on the departmental exam. They'll show a division problem, and they'll just say, what are the non-permissibles for this? And you have to recognize, oh, it's going to be all 3. So it's not even doing the problem. It's just finding the non-permissibles. Okay, so I've seen that come up before. They do like them. So I have to consider 3x, x minus 3, 5, and x minus 3. So here, my non-permissibles would be 0 for 3x. What would it be for x minus 3? 3. For 5, it wouldn't be anything. And then for x minus 3 again, it would still just be 3, so I don't have to write it twice. So the only ones here are 0 and 3. Okay? So that is kind of tricky, because you have to remember that it's all 3 sections. It's probably the toughest thing about division.